Hi everyone. In this video, we are going to see about the measurement of attenuation by cutback method. The communication engineers need the fiber characteristics to design the optical fiber link with an efficient waveguide structure without any loss or dispersion. Similarly, the fiber manufacturers need the fiber characteristics to do further improvement on the fibers. Generally, the fiber attenuation measurements are used to determine repeater spacing and light source power. Dispersion measurements are used to determine the maximum bit rate. Refractive index profile measurements are used to know the number of modes propagating the fiber and to determine its numerical aperture. So in this video, we are going to see about one of the measurement of attenuation by cutback method. Here the figure shows the experimental setup to study the attenuation characteristics of the fiber for each wavelength. Light from a halogen lamp or a white light source is coupled into the experimental fiber having a length of about 1 kilometer. The lens placed in front of the source focuses the light onto the interference filter or monochromator from prism or grating. The light with a given wavelength is incident on the chopper, which is used to convert DC light into square pulses of light. That is, it converts it into a AC light. It also sends the reference signal to the lock-in amplifier. Monitor is used to view the intensity of the optical beams. The cladding mode strippers are connected at the input end and output end of the fiber. The cladding mode stripper is used to remove the cladding light or cladding modes. Normally, the plastic jacket covering the fiber over a length of 50 mm is removed at those input end and output end of the fiber. Then the jacket removed for the fiber is placed in an index matching liquid whose refractive index is slightly higher than that of cladding. This arrangement is called cladding mode stripper, which will attenuate the light propagating through the cladding. After traveling through the fiber for 1 kilometer length, the given height reaches the index matched photodetector whose output is given to the lock-in amplifier. So the lock-in amplifier delivers an output P suffix L lambda to the recorder or nanovoltmeter. Then the fiber is cut back, leaving typically 2 meters of the fiber, and the experiment is repeated. In this case, the output power, that is, here it is mentioned as P02. The input power is mentioned as P01. This procedure is repeated for other wavelengths also. Thus, the fiber attenuation at a given wavelength lambda is given by lambda in terms of decibels, which is equal to 10 divided by L1 minus L2. That is the length of the fiber cut back in kilometer, to the log of P02 divided by P01. In the case of multimode fibers, there are mode scrambler used to get the uniform intensity distribution among all the modes, an order sorting filter acting as a mode selector to determine the fiber loss for each modes. So here the advantage of this method is this method output is very accurate and simple, and also some of the drawbacks which are actually faced in this particular method, it cannot be utilized to find the fiber attenuation in a working fiber optical link. That is, in that case, optical time domain reflectometer, in abbreviation it is called as OTDR, is used. It is a destructive, this particular method, this cutback method, is a destructive testing method. But when you use an OTDR instrument, that can be used both in the laboratory and field measurements for determining the fiber attenuation, joint losses, and detecting fault losses. When the fiber attenuation varies with the distance, then the OTDR is the only instrument which can measure the fiber attenuation along the fiber optic link. The OTDR measurement is a non-destructive measurement. So the principle which is often called as the backscatter method, that is in OTDR. It is based on the measurement and analysis of the fraction of light which is reflected back within the numerical aperture of the fiber due to Rayleigh scattering. We will discuss about it in the next lecture, next video. Thank you.